is given below. Using the graph, calculate the distance covered by the graph. Now we can see that this is a speed time graph, and we can see speed is in meter per second and time is in second. So both are given in SI units only. So we have to find the distance covered by the graph. We know that area under the speed time graph gives us the distance covered. If it had been velocity time graph, then area under the velocity time graph gives us the magnitude of displacement. Now we can see here the graph is AF, and area under the graph means either you can take trapezium OAFH. So area under the graph means area of this trapezium you have to calculate, or what we can do is area of the triangle AFG plus area of the rectangle OAGH. This will also give us the same. This will be equal to area of the trapezium OAFH. So let us calculate area of triangle and area of rectangle. We know that area of triangle is half into base into height, that is half into AG into GF. So S is area under graph, area of triangle plus area of rectangle. So what is here AG? 50 minus 0, 50, and FG is 30 minus 5, 25. So half into 50 into 25 will give us area of triangle, plus 5 into 50. What is 5 into 50 here? Area of rectangle OAGH. OA into OH. So that is 5 into 50 gives us area of this rectangle. So when we do the calculation, we get the answer to be equal to 875 meter. So area under the graph, which is equal to distance covered, is 875 meter. And out of the 4 options given here, we will choose B option, which is 875 meter. This is the correct answer. Now next MCQ. Which one of the following graphs shows the object to be stationary? So all the 4 graphs here are different. First is distance time graph, second position time, third velocity time, fourth acceleration time. Now in the first graph, distance time graph is a straight line inclined to time axis, and we know it means that equal distance is covered in equal intervals of time. So this is a case of uniform motion. So A graph is for uniform motion. If we have a look at the graph B, it is a position time graph where the position remains same as time passes. So when the position remains the same, does not change, it means the object is at rest. So B is obviously correct. Let us just have a look at C and D. C is velocity time graph, where the velocity time graph is a straight line parallel to time axis, which means velocity value, magnitude does not change. So that is a kind of uniform motion along a straight line where velocity is not changing. Okay. And last is acceleration time graph, straight line parallel to time axis, which means acceleration value remains constant. So it is a graph for uniformly accelerated motion. So for the object to be stationary, we have seen the only correct option is B. Okay, where the position is not changing with time. And we know the definition for an object to be stationary is when it does not change its position with respect to surroundings with the passage of time. Now our 9th MCQ is, Newton's third law of motion explains the 2 forces, action and reaction, are coming into action when the 2 bodies are in contact with each other. These 2 forces, there are 4 options given, always act on the same body, always act on the different bodies in opposite directions, have same magnitude and direction, acts on either body at normal to each other. Normal means perpendicular to each other. We know that action and reaction, what is Newton's third law of motion? Action and reaction are always equal and opposite. It means they have same magnitude, but they have opposite direction. And we know that they act on the different bodies in opposite direction. So always act on the same body is wrong. Always act on the different bodies in opposite direction is correct. B option is correct. Let us have a look at the other options also. C's have same magnitude and direction. Magnitude is same, but direction, no, it's opposite. D is acts on either body at normal to each other. acts on either body is correct, but not normal to each other always. So B is the only option which is correct. Now, the next MCQ is, in a rocket, a large volume of gases produced by the combustion of fuel is allowed to escape through its tail nozzle in the downward direction. You must have seen the pictures of rocket. So its head is shown in the upward direction, tail is downwards. It is shown vertically normally on the page or in any book with gases coming out from the tail. So in a rocket, a large volume of gases produced by the combustion of fuel is allowed to escape through its tail nozzle in the downward direction with large speed and makes the rocket to move upward. Which principle is followed here? Moment of inertia, conservation of momentum, Newton's first law of motion, Newton's law of gravitation. Now, you know it's not Newton's first law of motion because that is the law of inertia, which is not applicable here. Newton's